Okay, I'm going to go over a proving identity problem kind of slowly and just see if we can make some sense of these questions. Okay, here's the question. We've got sine 2x minus cos x over 1 minus cos 2x minus sine x, and we're supposed to prove that it equals cos x over sine x. So we got to choose a side, and we choose the more complicated side because it sort of makes sense. And one of the principles that they gave in the book was you need to take the sine 2x and cos 2x and turn it into just sine and cosine of x, of a single variable. Well, excuse me, the sine 2x is pretty straightforward because there's only one thing you can do. There's your formula. You've got a formula, and it says what you have to do is if you see the sine of twice an angle, you can write 2 times the sine of the angle times the cosine of the angle. So they give you a mark for just taking sine 2x and rubbing it out and putting 2 sine x cos x. You're locked in there. But then it comes to this cosine 2x, and you've got 3 different things that you need to do, or you could do that. 3 different things. But you look at this 1 here, it kind of tells you what to do. Because this 1, if you could subtract 1, then that would cancel. And you'd lose a 1 from one of these things, and the whole thing would just get simpler. So you look at this 1 minus something. So I'm going to put a bracket here. The reason you choose 1 minus 2 sine squared is because you're going to go 1 minus 1, and the 1s are gone. And that's pretty terrific. And then minus 2 sine squared is going to turn into plus 2 sine squared. The thing just got a whole lot simpler. So that's why we choose to take, instead of cos 2x, we go 1 minus 2 sine squared x. Okay. Now, a lot of these questions are about factoring and canceling. So if you can factor, it's sort of a good idea to do that. Well, by factoring, it means you look at both of these things and you say, what's common to both? And what's in both is cosine x. So you can go cosine x times 2 sine x, and it gives you this first thing. And cosine x, you have to decide what to put in here, minus 1 gives you this cosine x. There it is. You factored out a common factor. Well, in this one, we went 1 minus 1 is nothing. It canceled. Minus 2 sine squared gives me positive 2 sine squared. But you look at this thing, and now it's time to look over to the right, too. Hey, I've got the cosine x here all by itself. Now, the only way this question could work is if something up here was going to cancel with something down here, so I'll just be left with sine x here. Well, factor and cancel. Let's think here. Okay, I'm going to factor out sine x is in both of these. So I see a sine, I put the sine x down, then I put a bracket. Well, the only way this is going to work is if 2 sine x minus 1's up here, it must be 2 sine x minus 1 here. And then I think, does that work? Sine x times 2 sine x, oh yeah, that's 2 sine squared x. And sine x times minus 1, that's minus sine x. So factoring, the common factor is sine x in the bottom, and you're left with 2 sine x minus 1. Well, anything divided by itself, including this bracket, 2 sine x minus 1, anything divided by itself is equal to 1. It just cancels. And all you're left with is cosine x, cos x over sine x. And that's exactly what you wanted. That is the right-hand side. So you've just proven that the left-hand side is equal to the right-hand side just by making some clever choices right here for cos 2x, so it's simplified, and then factoring and canceling and realizing that the thing that's going to cancel has got to be the same, top and bottom. I hope that helped. Okay.